Our today's topic is expressing a set. How we can express a set. What are the different forms in which we can represent or express a set? Let's see what are the different forms or types in which a set can be expressed. We have already discussed in our previous lecture of sets where there are two forms in which a set can be expressed. Let's see what were those, and we are going towards more advanced version of expressing a set. We have already seen the descriptive form of set. We will have a short intro here, then we move towards this advanced form. Then the tabular form of a set. Tabular form, both of these forms has already been discussed in our previous lecture. You may refer to our playlist of sets where it is already given. And the third form that we will discuss today is set builder form. Okay, so these two have already discussed. We have already discussed these two forms, and our today's focus will be on the set builder form. Let's have a short intro of descriptive form and the tabular form. Then we move towards the set builder form. What is descriptive form? We can say that descriptive form is the set described in the form of statement. When the set is described in the form of statement, it will be called as descriptive form. For example, we have an example: n is equals to set of natural numbers. Okay. Similarly, if we have z is equals to set of integers, these are the examples how you can write or express a set in the descriptive form. Then we move towards the tabular form. What is meant by tabular form? Tabular form is basically a form in which you list the elements, or you can say listing of elements within braces and each element is separated by comma. And each element is separated by comma. So when you write a certain set in such form, it will be called as tabular form. For example, if we write this descriptive form in tabular form, it will be written as, let's see how we can write this descriptive form in tabular form as n is equals to 1, 2, 3 up to so on. And the set of integers can be written as z is equals to -5, -4, -3, -2, -1 up to so on. So this is how you can write or express a set in descriptive and tabular form. But we have already discussed them in detail. It was a very short overview, and our main focus is on the set builder form. What is the set builder form and how we can represent a set in set builder form? And let's see this with the help of examples, and why do we use a set builder form. Let's see. Set builder form. We will start from its definition, as the definition is very important to have the basic concept of basic concept of any term. Okay, it's it is defined as it is a mathematical notation. It is a mathematical notation for describing a set describing a set by stating properties that its elements must satisfy. Okay, this is one of the definition of set builder form. Okay. It is also defined as it if a set is described by using a common property by using a common property of its elements is called set builder form. The purpose of stating the two different definitions of a set builder form is that if you have some confusion in its first definition, you can understand the concept by its second definition, that is quite much simple as compared to the first. Okay, so set builder form is a mathematical notation for describing a set by stating properties that its elements must satisfy. Or if a set is described by using a common property of its element, is called set builder form. That is, if we describe a set by choosing a specific common property of its elements, then it is called a set builder form. It was just a statement. Let's have a concept by example. We have a few examples how we can represent a set builder form. We will start from P is equals to P is a set of prime numbers. This is the one form in which we can represent the or express a set, and this form is called the descriptive form. This is a descriptive form. Now, if I want to write it in the tabular form, how I can write that? It will be written as P is equals to 1, 3, 5, 7, 11 up to so on. Now, what is this? This is a descriptive, this is the tabular form of the set P. Okay, this is a tabular form. Now, let's see how we can write how we can write the same set of prime number in terms of set builder form. Let's see. It can be written as P is equals to, I will write it first, then I will describe each and every part of this form. prime number. It's a prime number. Now let's see how you can read it. How you can read it? You can read it like set of all x such that such that such that x is a prime number, or x belongs to prime number. So this is the set builder form of the given set of prime number in of the given set of prime number in that is represented in this form. So we can say that this is the set builder form. Okay, so this is how we can write a set builder form. We have to write the curly bracket start from here, which represents set of all. Then after that we are having a variable. It could be any, it could be a, b, c, p, q, or any variable. It's x. Then such that we this line that represents such that. After that we will represent the value of the x, that what is the property of x. Actually here the property of x will be it is a prime number. So it means that all the elements that will be in this set of p will be all the prime numbers. So this is how we can represent a set builder form. Okay, now let's see why we use this set builder form. What is the purpose of representing the set in this little bit difficult form as compared to descriptive and tabular form? Now we'll see why set builder form. It's a very important concept to it's a very important concept that you should know, that what is the importance of this set and why we represent the set in this form. It is mostly used, it is one of the reason behind using this set builder form is it is mostly used for representing sets of large number of elements or infinite of large number of elements or infinite. This is one of the main reason behind this. It means when you have to represent a large number of elements or infinite number of elements, then you need a set builder form. Now let's take an example so you can understand how it is possible. For example, we have a set of integers from 2 to 6. How you can represent it? You can represent it as 2, 3, 4, 5, and 6 in tabular form. Say for example, in tabular form, if I will say set of, another example is set of real numbers in same interval as above from 2 to 6. Then how you can write that? Let's find out. Let's write it down as 2, 2, 2.1, 2.01, 2.001, and up to so on. Now, is this possible to write a set of real numbers? Is it possible to write the set of real numbers in this way? That is this the right way to represent a set that has a infinite number of elements or large number of elements? So in order to represent a set in a proper form that is of infinite number, we have to use the set builder form. So this set can be expressed in set builder form as, what was that? We have a set of integers between, let's have a simplest example, between 2 and 6. It means 2 and 6 are not included in the will not be included in the series. Now how you can write it in the form of, we will write it in every form. If we will write in tabular form, it will be written as z is equals to 3, 4 and 5. Okay, and if we write it in set builder notation, we can write it as x such that x belongs to integers and x is greater than 2 and less than 6. So this is how we can represent this set of integers between 2 and 6 in the set builder form. So it will be how we can read it as set of all x such that x is an integer between 2 and 6. So this is how we can represent a certain series. So this is how we can write a certain set in mathematics in terms of the tabular form, when we have a set that have that is of range that you can not describe in the tabular form, or you cannot explain it in the descriptive form. Then we use the set builder form. Let's have another example. Another example is set of all integers except 11. Now this is also a set that is that is of large number of element, or that is, you can say, an infinite set. So how we can represent it in set builder form? Set builder form will be write it as, let's say the set is A is equals to such that x such that x belongs to integers and x is not equal to 11. So this was another form of set builder form. This was another example of set builder form. Let's see how you can read it as set of all x such that x belongs to integers integers and x is not equal to 11 to 11. So in this form, this notation represents and symbol, that this condition must also be satisfied. Okay, so this is how we can write the set of integers, that is an infinite number of that there will be infinite number of elements in this set. And how we can write it in set builder form, we can write it in this form. This is the easiest form you can use. Firstly we will start from brackets, then we use any variable that will represent the element of the set. Then we will say that then we represent its property, that those elements belong to which type of numbers. And then we will say there are three parts here. For your convenience, we can say there are three parts. This is the part 1, where you are assigning a variable. Then the part 2, where you are assigning, or you can say you are representing that that variable belongs to a certain type of numbers, and in this case it belongs to integers. And then a condition, that is part 3, condition. So this set form is made up of three parts, part 1, 2 and 3. In part 1 we represent a variable, in part 2 we represent the type of that variable, in part 3 we represent the condition. So this is how we can represent. Now we will see few more examples. For example, we have some examples, as let's have an example of finite numbers. Let's E is a set of even numbers. It means you can represent any set in terms of set builder form. It is not necessary to represent only those sets that are infinite, that are of the property of infinity. No, you can write any set in set builder form. Let's see how. Set of even number between 1 and 10. Now this is a finite set. So let's see how you can represent it in set builder form. It will be as E is equals to x such that x belongs to even numbers. And what is the condition? And a set of even between 1 and 10. It means between, it is not equal to 1 and 10. So we will say x is greater than 1 and less than 10. So this is how we can write the set builder form. So this is the part 1, assigning variable. Now after this is the part 2, assigning type of variable, or the value of variable, or the sets to which this variable will belong to, assigning the type of variable. And then the part 3, where you are applying condition. So this is a very easy form in which you can represent a set, by which you can represent a set builder form, by dividing it in three parts, one by one, assigning the values, or assigning the variables or types, or applying the condition. So this is how we can represent a certain number that is even not an infinite number. We can also represent the normal numbers in terms of set builder form. Hope so this lecture has helped you a lot in understanding the concept of set builder form, and how you can represent it, and what is the definition, and why we use the set builder form for representing the sets. Thank you.